Welcome. Having understood the different layers of a data platform architecture, now we are ready to dig deep into the data warehouse architecture. So that's what we are going to talk about in this module. So in order to start designing a data warehouse, it's important to understand what are the different types of business data that are available. Typically, business data comes in facts and dimensions. Once we have categorized this data, how do we model this data in a data warehouse? So there are a few different schemas like the star schema and your Snowflake schema in which a data warehouse can be architected. And finally, because your data warehouse is for complex queries, we are also going to talk about the idea of a data cube and some of the data cube operations. So let's get started. So let's get introduced to the data warehouse architecture. EDW stands for Enterprise Data Warehouse. So in the previous video, we looked at the different layers of a high-level data platform. A typical enterprise data warehouse architecture has a lot more components, right? So you have your different data sources, and then there is something called a staging area, your storage layer, which is containing your data storage and some processing. So here you can see that between your data warehouse and your data mart, so there is a hub and spoke kind of model where you're also storing the metadata, and then your user interface and analysis layer. So just to refresh, a data warehouse architecture always depends on the enterprise use case. So it's important to determine what is the use case for developing this architecture, right? Typically, it is for report generation and dashboarding, or to do exploratory data analysis by your data analyst and your scientist, and further do automation and machine learning, or some sort of self-serve analytics. So now that we have seen the sort of deep dive of a data warehouse architecture, so it's important to understand how do we go about creating this data warehouse? How do we model a data warehouse, and how is it different from the data modeling of the RDBMS systems that we have looked at? So in order to understand that, you should understand the different types of business data. Facts and dimension modeling is a very key concept of data warehouse architecture. So it's important to understand what are facts and dimension, and what is a fact table and a dimension table. Business data typically can be categorized into facts and dimensions. So facts are quantitative measures, right? So typically examples are temperature values, the number of sale, the bill amount, rainfall in millimeters, etc. are quantitative measures, which are essentially facts, which are important for your business process. Then next comes the dimensions, which are attributes relating to the facts. So they provide context to the fact. For example, when we talk about rainfall being 25 millimeter, it's important to understand, hey, in which location and at what time, right? So these add context to the fact. They are also often called in the machine learning context as categorical variables. So these are facts and dimensions that a typical business data can be classified into a set of facts data and set of dimensional data. Having understood facts and dimension, so a fact table is typically a table that contains details of the fact. So a fact table usually is centered around the business process. That's very important, right? And facts can also be aggregated. So let's take a look at the diagram which is on the right side. So you have a sales fact table which talks about sale of a particular product. So you have the product information which is dimensional, your store, but you have your facts which is, hey, the dollar sold, how many quantity units sold, and the dollar cost, right? So a fact table has to be associated with dimension table, right? So dimension table stores all of the dimensional data. So they categorize the facts. So typically a dimension table is used for filtering, grouping, or labeling of your facts, right? So typically, as we can see here, your product dimension, your geographical dimension, right? Or your person details like your clerk here, right? The person who sold a particular product. So a fact table has multiple dimension table associated with it. And how are they connected? In a typical relational databases, a fact table has foreign keys to the dimension table, right? So here we can see the fact table is connected to time, when the sale happened, connected to store, which store, the location of the store, and then the person who sold, the clerk, the sales clerk information, the product information, your customer information, what's the customer profile, and your promotion information. So there are typically 3 types of facts table. Okay, so let's take a look at what each of them are. So there is the transaction fact table. So very similar to the sales table that we looked at, right? Then you have a snapshot fact table. So, and then a accumulating snapshot fact table. So the illustration on the right in this slide gives us a example of a snapshot fact table. A snapshot fact table is a daily balance fact that can be summed through a particular dimension. For example, a customer dimension, or it could be time dimension, right? So here in this example, we do have fact table which is inventory snapshot daily, then inventory snapshot monthly, inventory snapshot yearly. So there are sometimes your snapshot fact table can also be periodic facts, right? Snapshot of the activity at the end of the day, the week, or the month. So this essentially gives us the aggregated information across a particular dimension. So if it is time, of course, there are different granularity of time that we can look at, but it could also be across another dimension, like, such as your customer. So next we look at your accumulating snapshot fact table. So your accumulating snapshot fact table contains the accumulated information which is the activity of the business process with a well-defined beginning and an end. So here if you look at the example that is being given here, so you see this corresponds to a warehouse inventory accumulating fact. So there are different sort of the day at which the product order is placed, the day at which it is inspected, the day at which it's shipped, it's boxed. So there are different steps to a business process, right? So remember, in a data warehouse, we are shifting our context from not the transactional software writing, but how do we get a better understanding of the business process, right? And to do analytics on it. So the accumulating snapshot fact table understands the business process and the different steps that are involved in that process, right? So it's used to record events during a well-defined business process. So you will have multiple sets of dates, multiple sets of steps. So as the steps goes through, so it gives you the complete snapshot of the business process, right, at a particular point in time. So now that we have looked at the different business data, the facts and dimension, and the fact table and dimension table, and the different types of fact table that can be there. So now we look at data modeling of this information. So there are typically 2 types of schemas in which your data can be organized in a data warehouse. So we already saw typically a fact table is connected with a dimension table using keys, right? So in a star schema, it's typically like a star. So the dimension radiate from the central facts. Okay, so you have a fact table and each of the dimension is radiating from the fact table. So it adds context to a particular key of the fact, right? So your location, your customer information, the store ID, etc. And a star schema is typically denormalized. You can extend on the star schema to make it a snowflake schema. So a snowflake schema is an extension of the star schema technically. So it is a normalized star schema, right? So you're dividing your dimensional data into sub-dimension. So if you remember the store information, so you had the store ID, some of the attributes of the store, but there was also location information. So that could be a sub-dimension, right? So dimension tables can be split into child table. So typically it's normalized, but Snowflake schema can also be not fully normalized. So now let's look at what are the steps of modeling with the schema, right? So the first thing to understand while modeling with a schema is to understand the business process. So a typical business process is point of sale, POS transaction, point of sale at a particular store, right? And then choose in your fact table what is the level of detail, because you always want to start with a transaction fact table. From there you can go into your snapshot fact table and your accumulating snapshot fact table, right? So you choose the level of detail at which facts are available. So it could be the individual line item of sale, for example. So for an individual line item, which is the fact, find out how can you break them into what is the actual fact, your quantitative measure and your dimension, right? So your date, your product, store, the cashier information, which is the clerk information, are typically your dimension. Then you identify your facts. So your amount, the quantity, any sort of discount or your sales tax. Then you put them together in a star schema, right? So you can put them as purchase being the central fact, and then the different dimension as radiating from the centralized fact. And then you can break each of these dimension into sub-dimension. For example, your product can have just a name and ID, which can be further divided into the brand information. Similarly, time can further be divided into a yearly, month and daily kind of information. So now that we have seen the fact and dimension modeling, so let's sort of take a step back and compare the entity relationship model that we looked at when we did RDBMS, right? And the dimension modeling. So this helps us to sort of see this difference. So in an ER model, the relational model is typically for your online transaction processing system, right? So where the entities correspond to your business entities there. Here in your dimension modeling, it's used for OLAP systems, which are where you have your facts and dimension, and it's on which is the business process you want to optimize or understand better. So your ER system is optimized for data update, where data is written, whereas your dimensional modeling is optimized for data retrieval, for writing your complex queries. So your ER model typically contains both the physical and logical model, whereas your dimension model is typically a physical model, how data is actually stored in your data warehouse. A ER model is normalized. So we have seen the different types of normalization, 1 and 2 and etc. Whereas your dimension modeling is denormalized. So that's why we have to see, typically as we have seen, the star dimension is denormalized. Your Snowflake is a little more normalized, right? Normalization, quick recap, is reducing redundancy of your data. So one of the very important things to understand, right? Your ER models the micro relationship between the data elements, right? How is it? So it's all about the customer journey in terms of, hey, how do we make your software as efficient as possible to make data, to write it in the way your customer will look at it, right? Whereas your dimensional modeling models the macro relationship in the data element towards a deterministic strategy of understanding the business process, right? You are trying to understand and do business intelligence on it. So it is about, hey, what are the different aspects of the business you want to look at? So ER model tables are the unit of storage. Here, cubes are the unit of storage. We'll talk about cubes in a bit. So there is wide variability of structure of ER model. whereas all dimensional models serve as equal entry point to the fact table in your star schema. ER model is meant to maximize data redundancy, improve data consistency between entities, whereas your dimensional modeling is to maximize data understandability. So this is important. So let's take a minute to digest this information, right? So from the OLTP kind of database, now we have sort of gone into an OLAP, analytical processing, and how the data modeling plays a very important role. So we have always constantly gone ahead to understand how data models play, right, based on the context in which the for the application per se. So now let's take a look at data cubes. So data cube, as the illustration represents, is a cube of data, right? So in a typical OLAP data based data store, you are looking at multi-dimensional data to understand the business process, right? Understandability of the business process is the key thing. So a data cube is a typical unit of storage for a data warehouse. So a data cube helps to store multi-dimensional array of data. Multi-dimension, sometimes in technical terms we'll call ND, N-dimensional it stands for. So it's used to represent facts along some of the dimension of interest in an enterprise data warehouse. So each of the cell is the fact itself. So there are typically multiple data cube operations that you can perform, right? So you have a data cube, which is, so in this illustration, we have done a 3-dimensional cube. Of course, it can be higher dimension depending on what are the different dimensions for your business process, right? So let's look at each of the data cube operations. So once you have your data as a cube, then you can do a bunch of different operations to aggregate data at different levels, right? So the first kind of operation is either a drill up or a drill down, right? So your drill down is drilling into the subcategories within a dimension. So let's say, for example, your product is a t-shirt. So you can have multiple subcategories in terms of the size of the t-shirt, right? So you want to see what kind of subcategories you want to look at. So drilling down into, from the dimension, the sub-dimensional data. Whereas if you want to drilling up is aggregating at the level of categories, right? So you, because each of it gives you different types of aggregation, and both of it is relevant for the business operation. So when you are looking at a product perspective, then you want drilling up information, drilled up information. Whereas if you are looking at, hey, for a particular product, hey, let me understand the different subcategories, right? So you want to drill down. So then comes the rolling up, right? So you're summarizing a particular dimension. So here, if you look at it, your so summary typically can be your count, minimum, maximum, sum, or average information, right? So you are aggregating on a particular dimension of your data cube. Then you have slicing. So slicing, as you can see in the physical example, the illustrations shown, you're slicing the cube like slicing a cake, right? So you're reducing your cube dimension by 1 essentially. So you're essentially just taking a slice of your data cube to look at it further down. Then you can do dicing, which is essentially reduce dimension of the cube, right? So instead of it being a 3-dimension, you can just look at, hey, you want to aggregate all the information in a particular dimension so that you can dice it, right? So dicing is a sub-cube of that data cube. So again, remember, here we are representing it in a cube information illustration, but typically your data is multi-dimensional. That's why it's multi-dimensional array of information. Then you can also do pivoting, which is changing the perspective of the cube. So you can sort of start turning the cube around to understand the data from different perspectives. All right. So let's summarize the learning from this module. From the different data layers that we looked at the previous module, we have looked at data warehouse architecture in a more detailed manner. In order to start architecting a data warehouse, it's important to understand the different data that we store in the data warehouse. So typically the facts and the dimensions, right? So once you have the facts and the dimension, there are different data models that you can apply, a star schema and a snowflake schema. And then finally, we have seen the concept of a data cube, which is the primary unit of storage in a data warehouse, right? And then what are the different operations that can be performed once you have data in data cube, which essentially represents multi-dimensional data. Alright, so in the next video, we will do a hands-on on all of these so that we'll get a better understanding of it. I'll see you in the next video.